What is the fourth industrial revolution? There have been 3 industrial revolutions in the history of mankind. The first was the mechanization revolution, represented by the invention of the steam engine, which led to the birth of modern industry. The second was the invention and popularization of electricity at the end of the 19th century. The third industrial revolution, also related to electricity, was the information revolution that began in the 1950s with the invention of transistors, integrated circuits and electronic computers. Digitalization has completely changed the world and our lives. Humanity is in the midst of a fourth industrial revolution. The most recognized element of the fourth industrial revolution is artificial intelligence, AI, which is undoubtedly revolutionary, and may even revolutionize the lives of human beings, and the scenario of robots wiping out human beings in a science fiction novel is not unfounded in today's world. But even if we know this risk, the major countries competing for world leadership will never dare to give up AI research, otherwise their own soldiers will have to use their flesh and blood to fight against other countries' AI robots in future wars. Advanced digital production, ADP, powered by AI, 3D printing, and other digital technologies, is an important part of the fourth industrial revolution. The revolution has the potential to cause social upheaval, as a large number of jobs that involve mental labor and skilled manual labor will be replaced by AI. The fourth industrial revolution is characterized by the convergence of the digital meta-world, the physical world and the physiological world. Let's look at another area of the fourth industrial revolution, green energy. Semiconductor technology originally used in the information industry is being transferred to the new energy industry. Photovoltaic technology is likely to eliminate the huge fossil energy industry, coal, oil, natural gas, that was built up in the first industrial revolution, and allow mankind to realize zero carbon dioxide emissions. On the energy use side, more energy-efficient semiconductor LEDs are replacing traditional thermal light sources. Electric cars are on their way to replace gasoline cars, which require more semiconductor chips than gasoline cars. AI-enabled cars can drive themselves, freeing up human drivers. Self-driving cars will be safer, and future city roads will not need traffic lights, but will be rapidly negotiated by the car's AI over a 5G network. In the sky, small drones are already electric, using quadcopters instead of single rotors like helicopters. While single-rotor planes require a complex mechanism to control direction, quadcopters can be easily controlled by computers to simplify the mechanical design. Although everything grows by the sun, the photosynthesis of plants can only utilize 2 very narrow frequency bands in the sunlight, and most of the light energy cannot be used. If the sun's energy is converted to the appropriate frequency of the LED, the efficiency will be greatly improved, not to mention the light energy can be transmitted through the power grid from the distant desert. The future of LED agriculture can be built like a building layer by layer, each layer with LED lighting, only a small amount of water resources, acres of 10,000 pounds is a piece of cake. Industrial agriculture. This integration, traditional agriculture may be eliminated. On the other hand, supercomputers and AI have already played a role in medical research and development. In the past, engineers liked to call computers and other electronic technology weak electricity, and electric motors, electric lights, and other strong electricity to distinguish. But scientific computing, as well as big data and AI to bring massive computation, has pushed the energy consumption of data centers to astronomical levels. On the one hand, this promotes energy-saving architectural innovations such as storage computing integration, and on the other hand, it stimulates the research of quantum computation. The quantum computers being developed are capable of completing 100 million, or even 100 million, operations on an ordinary computer at a time, while consuming only a fraction of the energy, and are considered by some to be part of the fourth industrial revolution. Let's take a look at some of the key areas of the fourth industrial revolution. Artificial intelligence and quantum computing. The progress of AI is mainly built on the neural network algorithm that imitates the human brain. This algorithm was invented in the 1960s and was popular for a while in the 1980s, but fell silent again because it was not practical. The godfather of AI, Hinton, couldn't find a job in the United States, so he went to Canada to insist on his own research. On the basis of neural network, he invented many kinds of algorithms including deep learning, and in 2012, he and his students' AlexNet network made a breakthrough in computer image recognition, which triggered a new round of AI craze. The most landmark breakthrough in the field of AI was made by Google. They applied Hinton's deep learning algorithms to Go, an ancient game that is a supreme challenge to human ingenuity, and in 2016, Google's AI program AlphaGo defeated the Korean master Lee Sedol, and human chess players have never been able to beat a machine since. The following year, Google also launched the more powerful AlphaGo Zero, which can reach the highest level of human beings by self-training. Human intuition, big picture thinking, and other advanced intelligence are no longer mysterious. Today, people have begun to enjoy the fruits of AI applications from their homes to their travels. Some important application tracks, such as automated driving and natural language processing, are being followed closely, and in some cases, we are not lagging behind. 2023 At the beginning of the new year, a dialogue robot ChatGPT Fire. It can talk to humans like a real person and seems to know everything. It can help users write articles, do homework, and even pass the US doctor's licensing exam. Although there are still different opinions about it, it is likely to be another milestone in the field of AI. Its inventor is a research organization called OpenAI. Microsoft is one of its investors, and its co-founder, the famous Musk, says, "We are getting close to the kind of AI that is dangerous and frightening." The concept of quantum computers was proposed by American physicist Feynman and others, and in the 1980s, some theoretical physicists were already working on quantum computation. Since the 1990s, there have been a series of breakthroughs in algorithms. The establishment of the algorithm only proves that the quantum computer has the theoretical advantage, that is to say, the so-called quantum hegemony, to really build it out to overcome a lot of technical difficulties. At present, the quantum computer is still in the research and development stage. The technical route is the 8 immortals to cross the sea each show their ability, do not know who first put the road out. There are many ways to realize quantum bits, including superconductivity, photonics, and semiconductors, and the overall structure is also different between von Neumann and non-von Neumann. The fourth industrial revolution is upon us because digital technology connects almost every aspect of life and work. From cars to refrigerators to manufacturing equipment, more and more inanimate objects are becoming intelligent, using data generated by cameras, sensors, software, and other technologies to help us accomplish tasks, or even to perform them for us, learning with each interaction how to do our jobs more efficiently, and even using artificial intelligence, AI, to make decisions automatically. Of all the technologies ushering in this revolutionary new era, AI is arguably the most critical and complex. AI enables the autonomy of self-driving cars, teaching them how to safely and efficiently transport passengers and cargo from point A to point B, independently performing many of the actions, reactions, and decisions required. AI helps farm drones determine when crops need water, fertilizer, or pesticides and apply the right amount, and harvest them when they are ripe. AI allows robots to work collaboratively and independently of humans, and will one day turn factories into self-operating cyber entities that manage inventory, perform maintenance, and adjust production schedules to changes in demand without the need for human intervention. But for AI to work, it needs fast data that is processed and analyzed as soon as it is generated and collected, not a day or an hour later, as human intelligence can do. As Industry 4.0 relies on AI, fast data could even be the engine that drives the new revolution. The driving engine, processing power and huge memory banks. The first three revolutions. For most of human history, everything was handmade from collected materials, and at the beginning of the agricultural era, about 10,000 years ago, it was grown. The domestication and use of animals was revolutionary in itself, but industrialization really began with the introduction of machines into the production process. According to Tim Long, director of Micron IT, the first three industrial revolutions can be categorized as follows. 1. Mechanization. The first industrial revolution, which took place over a period of about 100 years from the mid-1800s to the mid-19th century, began with the mechanization of processes using water and steam power. 2. Electrification. In the late 19th and early 20th centuries, electricity was introduced into factories to enable assembly lines and mass production. 3. Automation. Digital technologies such as robots were introduced into manufacturing processes in the mid-20th century, automating many tasks previously performed by humans. The spread of computers in the second half of the century and the rise of the Internet in the 1990s allowed businesses to globalize their operations. Consumers could shop around the world with the click of a mouse. Each revolution has dramatically changed the way businesses produce goods and services faster, cheaper, and in greater quantities than ever before. Each revolution has also led to expanded markets and potential profits as products have become more readily available and cheaper. Industry 4.0, which is now underway, will bring about another dramatic change in business models and practices. Connectivity is the hallmark of this era. From cars to computers, robots to toasters, everything will be connected in the age of connectivity, communicating with each other and with people, creating unique user experiences and automating simple tasks in a variety of industries. By moving away from monotonous tasks, we can focus on more complex, mission-critical tasks, many of which will involve technology. Instead of making gadgets, people will design automated chemical plants. Instead of driving trucks, people will program them to drive information and troubleshoot problems. Instead of plowing, planting, and harvesting, farmers will manage technologies that do these tasks for them and spend their time maximizing crop yields. And this entire interdependent, connected digital ecosystem will rely on data to inform every step of every process. The data explosion. About 90% of all the data that exists in the world has been created in the last 2 years. Our devices generate 2.5 million bytes of data every day, a figure that is rising as the number of cell phones, tablets, computers, and other connected devices grows dramatically each year. The number of Internet users is expected to reach 4 billion in 2018, more than half of the world's 7.6 billion people. The number of connected devices on the Internet of Things, a network of objects connected to each other and to us through sensors, cameras, applications, the Internet, Bluetooth, and other forms of digital communication, is expected to reach 23.14 billion in 2018 and 74.4 billion by 2025. That's a lot of data, a gold mine, for example, for companies that want to gain insights into their customers' needs, wants, and buying behavior in order to improve their products and marketing approaches. Many companies use data in this way, batching data that exists for weeks or months and analyzing the results to determine where and how to fine-tune it. Huge volumes of data sit in unexplored lakes waiting to be sifted and examined, or often never examined at all. Nowadays, ignoring data seems to be a serious waste. The longer a data lake exists, the more stagnant and useless it becomes. However, the fourth industrial revolution has turned the lakes themselves into a waste. Static data will soon become obsolete. Fast is the trend. Speed matters. If you woke up to smoke and alarms, would you sit down and think before deciding to leave your home? Of course not, you would immediately recognize that there was a fire and run out of the house. Similarly, a truly intelligent AI must be able to process information, data, and adjust its behavior in real time, or as close to real time as possible. In a factory, this might be detecting a defective or damaged component and causing the robot to replace it with a different part before continuing. A machine cannot sit idle for weeks or months while software processes information. Nor should a robot ignore a damaged part and continue to assemble it, leaving the information to be checked when the resulting product fails. To compete in the age of connectivity, fast data is essential. There can be no delays, ambiguities or indecisions. In the case of a factory, a pause can be a disaster, a slowdown can lead to a shutdown, at great cost, reportedly $22,000 per minute in the automotive industry. It is clear that retrospective batch data processing, while useful for identifying trends and making decisions in response, will not be enough to enable companies to compete in Industry 4.0. Computers embedded in smart devices such as robots, drones, and autonomous vehicles must process data as soon as it is generated in a meaningful way, just as the human brain can. Processing at the speed of thought. How does our brain work? Information comes to us through our five senses, and our brains usually process and analyze it immediately. When we touch a hot pan, we don't have to think about what to do next. When we smell a flower, there is no delay between our nose and the rose. Our brains can process information, including thoughts, feelings, and emotions, very quickly. Computers can calculate complex mathematical equations much faster than we can, and can even play chess better than we can, but nothing is faster or smarter than the human brain at taking in information and choosing from a variety of possible responses. This is true for now. The fourth industrial revolution may bring computers closer to human capabilities than ever before. To avoid a collision, a self-driving car must process the accident and instantly choose a way to bypass the crash site. Factory robots should be able to detect and repair worn parts to avoid costly downtime. Drones must stop spraying pesticides when children or animals enter a field. The ability of a machine to do these calculations quickly depends on processing speed and memory, just like our brains. Industry 4.0 requires computers that can receive, sort and analyze large amounts of data in nanoseconds, not seconds or milliseconds, and Micron is working hard to develop faster, more efficient memory solutions to fully support AI. We see many opportunities for memory to play an increasingly important role in AI applications. Data is the key currency for enabling AI, said Mark Helm, senior researcher at Micron. Comparing the way a computing system performs transactional tasks, such as checking email or browsing the internet, a historical workload, to the way artificial intelligence operates, Helm said it's clear that data is a very important element of AI. This gives Micron the opportunity to be the custodian of data, Helm said. Whether it's GDDR6 DRAM that delivers data to the graphics processing unit, GPU, at the speed of the human brain, or DRAM and NAND memory products that stream data through the system, Micron products are the gatekeepers of AI data. The future of artificial intelligence depends on data moving at the speed of thought. Computers will be important enablers, and once they are able to process data at least as fast as the human brain, it will be a huge leap forward for civilization. To take mankind into this new realm, Micron knows that our businesses must operate faster, always ahead, as Helm puts it. At the heart of the fourth industrial revolution is the deep integration of networking, information and intelligence. In this technological revolution, production equipment, products, and people inside and outside the factory will be connected, collect and analyze relevant information, anticipate errors, and continuously adapt themselves to the changing environment. More and more technical systems or products are able to perform certain functions autonomously without human intervention. For example, a car equipped with GPS can know where it is. Through built-in microcameras and sensors, one system can recognize another. Through excellent programmed control, a system can independently respond to external conditions and optimize its performance to a certain extent. Through excellent programmed control, a system can independently respond to external conditions and optimize its behavior to a certain extent. In the fourth industrial revolution, the mode of social production will undergo profound changes. First, the mode of product production will change from large-scale manufacturing to large-scale customization. Artificial intelligence-based automation equipment and the Internet of Things, IoT, which connects automated equipment and management systems inside and outside enterprises, will make the research and development, production, and sales processes faster, more flexible, and more efficient. Simply put, consumer demand will be transmitted to factories in a more timely manner, and factories will be more flexible in switching production lines to meet different needs. The original large-scale manufacturing of a single product will gradually be replaced by large-scale customization. Secondly, the value-added area of industry will expand from manufacturing to service. Under the impetus of big data, cloud computing and other technologies, data analysis, software, and system integration capabilities will become the key to the competitiveness of industrial enterprises and a major source of profits. Utilizing big data to study customer or user information can open up new markets and create more value for enterprises. For example, with the help of big data technology, equipment manufacturing enterprises can provide predictive maintenance solutions and services to equipment using enterprises, which can extend the service chain and realize competitiveness enhancement and value added. Such as the General Electric Company was originally a manufacturing-based enterprises, but now the business field to expand to technology, management, maintenance, and other services. This part of the service has created more than 2/3 of the company's total output value. Third, programmed labor has been replaced by intelligent equipment. Due to the rapid development of digital technology, robots in the speed, strength, precision advantage on the basis of identification, analysis, judgment ability has also greatly improved. 2017 May, Artificial Intelligence Go program AlphaGo, and the world's top-ranked Chinese Go player KG3 games and all won, which shows that artificial intelligence in some of the game, but not all of them. This demonstrates that artificial intelligence has surpassed humans in certain analytical gaming areas. In terms of the production and service process, it was originally thought that repetitive, manual operations could be replaced by automated equipment. However, today's equipment is able to recognize a wide range of business modes, and is capable of performing non-repetitive, cognitively demanding tasks in a fairly wide range of areas. For example, computer systems have replaced some of the work of paralegals and patent attorneys in the law practice. Physical tasks that are environmentally complex or require human interaction were previously considered difficult to program and could only be performed by human beings, but thanks to advances in sensors, big data, and artificial intelligence, automation in this field has also made significant progress. For example, a robot bed can transform into a wheelchair and travel automatically, lifting and lowering itself to smoothly lift the patient into the wheelchair. In the future, most programmed work and some non-programmed work will be replaced by intelligent equipment, or assisted by intelligent equipment to greatly improve efficiency. The progress of the Fourth Industrial Revolution in the world's major industrialized countries shows that the Internet of Things, big data, robotics, and artificial intelligence technologies have opened up new space for the transformation and upgrading of existing industrial structures. Traditional industry has developed from relying on the functionality of monolithic equipment and the local reform of manufacturing units to the present day, and the room for upgrading capabilities has gradually become smaller, but with the help of digital technology, it is still possible to further optimize the entire manufacturing process and achieve the results of cost reduction and efficiency improvement. Not only that, but also the use of big data storage and analysis technology, the development of a variety of software, applied to the design, development, maintenance, and other high-value service areas, so that industrial enterprises at the same time both manufacturing and service functions, not only to meet the needs of the community, but also to increase corporate profits. The world's major industrial countries have begun a new round of industrial restructuring and upgrading with the help of digital technology, which will bring about changes in the global competition pattern in the manufacturing process, end products, production equipment, data analysis platforms, value chain, etc. Overall, the Fourth Industrial Revolution has brought about changes in the global competition pattern. Overall, the Fourth Industrial Revolution will greatly increase productivity, promote changes in industrial and labor structure, and further rewrite the course of human development. With every industrial revolution, the competitive position of the world's countries changes, with some countries rising to become the dominant players in certain fields and even in the world economy. In the First Industrial Revolution, Britain became the factory of the world by virtue of the steam engine and other technologies. In the Second Industrial Revolution, the United States of America became the world's industrial and technological hegemon by relying on mass production. In the Third Industrial Revolution, Japan relied on lean production methods to rise in the automobile and home appliance industries. The current Industrial Revolution, like the previous ones, is bound to cause changes in the economic landscape. Who seized the opportunity to achieve the fastest speed beyond the industry, enterprise boundaries of the smart connection, who will be able to take the lead in the era of mass customized production, who effectively apply the big data and intelligent equipment, who will be able to dominate the value chain, who successfully completed the transformation of the workforce, who will be able to make the rapid growth of national income. In this sense, the Fourth Industrial Revolution will not only reshape the future economic pattern, but also change the national competition pattern.